So welcome everyone to this webinar on SeaFEM. I am Daniel Sa. I will be guiding you through this webinar. Okay, so first of all, let's see the agenda we are going to follow. This is going to be a brief webinar, and well, first of all, we'll just do a brief introduction to SeaFEM, to see its technical features and capabilities and the most common applications. And then, which I think is the most interesting thing about this webinar, is we will through a full example for building a whole model for analyzing first the ratio of amplitude operators, and then analyze the same model with dynamic mooring. So then if there's some time at the end, we can do some questions, and if not, well, I will just issue my email so you can send the questions there. Okay, so let's begin with this brief introduction. So, what is SeaFEM? Well, it's a fully integrated suite of tools which will allow you to simulate and analyze the effect of waves, wind, and currents on any naval or offshore structure. Well, actually, anything which will be floating or even fixed to the seabed or to any other place, you will be able to simulate it and to see how this kind of phenomena, like waves and wind, will affect to your structure. So this integration tool includes also an FSI, fluid structure interaction connection with our solver for structural analysis, finite element and structural analysis. So coupled analysis are also available. Of course, the full package offers a complete and user-friendly graphic user interface where you can create or modify the imported geometry, define all the necessary data for the analysis, also generate the mesh, and of course post-process all the results. So digging into SeaFEM, it must be said that it can solve the dynamic response of the floating structure in the time domain, which is thanks to state-of-art radiation and diffraction solver, which is a very, very interesting thing. Solvers do it in the frequency domain. So that's a very important point to take into account. And so let's see some technical features. And as I mentioned, the potential flow is solved in the time domain using finite element method on unstructured meshes. Well, unstructured meshes is quite a point also, because it will allow you to manage any kind of geometry, no matter how complicated it could be. And regarding the analysis which can be performed with SeaFEM, of course, seakeeping, towing analysis, maneuvering, and also extinction tests. And of course, which is the sample we will be overviewing afterwards, this ratio of amplitude operators analysis. And well, as main features, or we have mentioned them, and then some special features which are also available. For example, nonlinear hydrodynamics is possible to be performed, slow drift effects, and also transom stern flows. Of course, these tools will allow you to perform quite precise and advanced simulations. And well, regarding environmental conditions which can be simulated, of course, regular waves, also irregular waves, which can be Jones-Swap or Pearson-Moscovich spectrum, or even user-defined spectrums. External forces can also be defined, external forces and connections. And, well, regarding performance, which is another important point, we have some conjugate gradient solvers implemented, and also a CUDA acceleration is available if you are using GPU units in your computer. And well, later on we will see some more on advanced TCL programming or scripting interface, which is also available in SeaFEM. Okay, so now let's move on to general applications, which are the applications most commonly used with the software. And as you can see, there are plenty of different applications can be analyzed. For example, of course, the motion analysis of ships and any kind of offshore structure in different sea spectrum and sea states. Response amplitude operators with corresponding white noise spectrum. Also, some maneuvering analysis like turning circle, which is very common in the naval world. Also, some more advanced analysis, like you can see here, like fluid structure integration, which is quite advanced. So hydroelastic models can be solved. Well, also some analysis on air cushion vehicles with waves and modeling the air cushion, which is quite advanced, of course. And well, once this small introduction is done, of course, later on you can ask any question or send me by mail. I think we can go directly through the example. So please allow me to get you to the interface so I can introduce it to you.